I'm Steve Kinney, Director of Technical Pre-Sales and Support for JAI, coming to you from the Automate 2011 show in Chicago, Illinois. This show brings together a wide range of industry professionals to look at the latest challenges and developments in machine vision. Those developments include trends towards high resolution, high-speed imaging, as well as a steady increase in the use of color for inspection. We'd like to show you some of the products that JAI is developing in response to those trends and products that we have on demonstration at the show here today. This is our new 8 megapixel camera, AB800CL. It features a large format quad tap Kodak CCD capable of delivering full 8 megapixel resolution color images at 17 frames per second. Output on this camera is via base camera link with GigiVision models soon to follow. For this demonstration, we're capturing images of these spinning jello boxes and sending them to the host PC as raw Bayer data. Interpolation software on the PC is converting the data into the full color images shown here on the monitor, both in the small real-time window to illustrate the full speed of the camera, and in this large image, which is displaying the full pixel detail achievable with the 8 megapixel resolution of the camera. As I said, this camera can deliver this full resolution Bayer output at up to 17 frames per second, or it can be set to perform the interpolation inside the camera. In that case, the camera outputs full 24-bit color information at 8.5 frames per second. And this, of course, is also available on monochrome models for inspection systems that need high resolution but don't need to distinguish color information. So now that we've talked about high-speed color inspection, let's talk about high-precision color inspection. This demonstration is focusing on color precision. By precision, we mean the ability to both precisely determine or match specific colors that you're looking at, but also spatial precision to inspect fine-level details like 2D barcodes, precise edges, or other details. For these types of inspections, Bayer interpolation may not be sufficient, and that's where JAI's expertise in 3 CCD prism-based color cameras comes in. JAI is one of only a very few vendors who offers high-performance 3 CCD color cameras for machine vision, medical, scientific, and other applications. In this demonstration, we're showing a side-by-side comparison of 2 different 1.4 megapixel color cameras. A standard Bayer color camera and one of JAI's newest 3 CCD color cameras, the AT140GE. Like the 8 megapixel camera, the standard Bayer camera uses a mosaic of filters on the CCD to capture the color information for interpolation on the host PC. This produces a good enough color image for many applications, but because the interpolation process must estimate the true color by combining color information from several surrounding pixels, it loses some degree of spatial precision. This can be critical in some high precision applications like print inspection of labels, magazines, or other materials, paint matching on vehicles, fruit and vegetable sorting, medical analysis, and other uses. What we see here in the demo, where we are looking for any label where the color is more than 2% away from our known good color, the Bayer camera catches and rejects the label that is well outside of the target tolerance, but it does not have the color precision to identify the label that is slightly out of tolerance, and therefore lets it pass on the inspection anyway. Meanwhile, our 3 CCD camera uses 3 separate sensors and a prism block to split the incoming light into separate red, green, and blue values for every pixel in the image, yielding extremely precise color information. Because of this, the camera is able to detect the label that is slightly out of range, as well as the one that is well out of range, making sure that both labels fail the color inspection as defects. We're showing a print inspection application here, but the same principle could be applied to analyzing medical samples under a microscope or the color paint on an automobile. At the same time, The 3 CCD camera sacrifices nothing in resolution. This allows it to read both the large and small barcodes on the packages, where the fuzziness created by the Bayer interpolation process makes the Bayer camera unable to read the smallest barcode. For applications where color is needed and tiny details must be discerned, designers of vision systems may want to consider using 3 CCD cameras to solve their issues. I hope this has given you a taste of some of the solutions available to solve your machine vision challenges. For more information, please contact us or visit jai.com.